Okay, we were talking about why the answer to this question is C, and the reason that it's C is because if you do an experiment in two different ways, you're going to come up with different answers. So, changing the procedure, you might be able to get an accurate answer each time. Accuracy is great. Man, you know how to read your scale, you know how to read your graduated cylinder. You are as accurate can be. You are the man, or you are the woman, okay? And you are going to find out what the correct numbers are. The problem is the procedure changed. Even though you're accurate, you have a target D from page 36 in your textbook, and it just isn't going to work. So you will not have you'll have accuracy, but you'll have no preciseness. And precise and accurate are very, very different. If you look at page 36, your precise guys are targets B and C. The accurate guys, C is not only precise, but it's also accurate. D is accurate too, but we don't know if it's precise because we only have one arrow in the target. You have to have more than one shot to see if you're getting preciseness. But you only need one shot to get accuracy, okay? And if you were shooting for accuracy and you were looking at letter D, you were not accurate. We're again referring to the targets on page 36 in the textbook. So that's how that stuff works. So I'm glad you remembered from yesterday. Let's see how you do on our next one. There we go. Yeah. Let's see what you do with this. As we look at our answers, we see 93% of you think this guy is false, and that is a very correct presumption. Let's see if we can get a feeling for that. 4.786. Let's say that was your measurement on a balance beam scale. There we go. So on the balance beam scale, how do we determine where the accuracy is? This is a centigram balance that we use. So what number is going to be accurate? The 4, the 8, the 6. What do we have? What are the accurate numbers? 4 is good. 7 is good. How about the 8? Okay, it's a centigram balance. 8 is in the centi column, the 1/100th. Okay? So yes, the 8 is good. But the centigram balance does not have a line to represent the 6. It just has a space between the 8 and the 9. There's lines for 8 and there's lines for 9. So because of that, our 8 is absolutely accurate, but 6 is our guess digit. You're always going to go for the last digit to be your guess digit. And that's why the answer to this guy was false, because you can't have two guesstimates. You can only have one. And so it's only going to be one number, and it will be the last number. Okay? So let's go on and see how you do with the next one. Oops, there we go. Let's start that question. Now you're going to see that what I've done is I've underlined the pertinent stuff. I've gone to the lengths here of using colors to group things, and you can see the 3.100 mils of liquid. That is all one thing. That's one of our givens. The mass of the bottle together, it's the liquid and the water together, is 6.30 grams. And then the empty bottle is 4.24. The empty bottle represents your graduated cylinder from the lab. Okay? The liquid, or the empty bottle, that's the mass. And then the mass with the bottle and the liquid together, the blue color, is our number that we get after we add the water. So when we subtract those two, we're going to get 6.300 grams, which is the liquid plus the bottle we have the 4.240 grams, which is just the bottle. And when we subtract these two, we get 2.060. And then we got the liquid volume. That was given to us, and that was a 3.100. Oh, we shouldn't do that here. Here, let's move this down a little bit. Whoops. Oh well, I guess we're going to erase it. So this guy is our grams, and this is the grams of the liquid. And the volume of the liquid was given to us right here. So the number, this is one of those problems where density is equal to mass over volume, and so we're figuring the density now. And oops, I just did that. That's the grams of the liquid, and the liquid itself, the volume, grams of liquid and volume of liquid, which is in mils. The volume is 3.100. Okay, and I trust that somebody has worked out that number. So as we look at our answer, you can see that the majority of the class was getting the A answer, which is correct, and the actual numbers, that the way they work out is going to be what? 0. What do we get? It's not quite exact. What do we get? 0.6 what? 0.66 what? 45? Okay, good. If that's what you see on your calculator, this is another good example of how to do your rounding. And let's move this up so you can see it in the back of the room. So we have how many sig figs here on the top? Let's give me an arrow. There we go. I can draw that. Okay, so sig figs at the top is 4. Down here is trailing zeros sometimes count. What makes them count? A decimal. Okay, so how many sig figs do I have here? Huh? What is it? 4. Yes. So we don't have to round this, do we? 0.6645. All right, so that's our good number, and that of course is grams per mil. How's that, folks? Huh? Are we good? Okay, let's go on. Do we have time for one more?